Welcome to the Ministry of Silly Talks. That is Lightning Talks. If you're not familiar with that, then let me give you a rundown. We're going to have a series of speakers come up. They're going to speak for 5 minutes or less on a topic, whatever topic they really want, so long as they are passionate about it and it's in the realm of programming. And if they try to go over 5 minutes, I start to do funny things. Now, what will those funny things be? It's to be determined, right? Stick around, right? We are Ninja Turtle themed, so in between each one of these speakers, I need to kill time, and one of the things I like to do is come up with trivia based on the theme of the event. So, are you guys ready? All right, there we go. There's that attitude I'm looking for. What do you call a turtle that surfs the dark web? A tortoise? Boom! Boom! If you did not enjoy that joke, you need to get on board right now. It is going to be a painful hour for you otherwise. All right. There are prizes. So if you can answer the pun before I lay down the line, all right, you get classic computer problems in Python, or for your favorite childhood friend, code this game. Yeah. Or for adults. Hold on, wait a second, guys. I got to read through this. This is fantastic. Now, this is actually by our keynote speaker tomorrow morning. Tomorrow afternoon. Meg Ray, absolutely. And code on by Meg Ray. She signed it. This is already worth $3,000. That's a big deal. All right, are we ready for our first lightning talk? Oh yeah, lightning talk speakers, you have 5 minutes. Not only will I be on your case, but this fine gentleman right here, Max, is going to be giving you a thumbs up for 1 minute, or a little billboard. Yeah, there you go. A little billboard saying, hey, you've got 1 minute. At that 1 minute mark, I want you dead set on ending in 1 minute. You hear me?
Okay.
All right. Give it up for our first speaker.
Hi, my name is Aditya. I'm a grad student at New York University, and I work with the Secure Systems Lab, who designed the update framework, or TUF, for software updates. Some of you may be familiar with that. And today I wanted to talk to you about Intodo, a framework we're developing to secure the entire software supply chain. So let's just take a quick look at how software is made. This is a super dumbed down version of a software supply chain where I've abstracted out some of the key operations that go into developing and putting your software out there. And each of these operations are vulnerable to attack, right? It's not unheard of for someone to get into repositories and try and install backdoors into software that eventually goes out to hundreds of thousands of users. Like, this is not uncommon at all. Similarly, someone can target your build systems and make you use compilers with backdoors, or it may even be something like you're building something malicious, or something that was compromised further upstream. They can mess with your package managers or your mirrors to distribute vulnerable versions of your software. And this is actually even more interesting because they can also target a specific audience in a specific region, which we saw with phpMyAdmin's Korean server. They can mess with your test servers, and they may be telling you things that aren't actually happening. So how can we fix this? There are a lot of solutions at each of these individual steps. You can sign your commits. You can use verifiable compilers or reproducible builds. You can put your packages out there in secure manners by signing them and distributing them via TLS or TUF, which, as it happens, is being implemented in PyPI now. But does that mean it's fixed? Not quite, because we have all of these gaps in between that still need to be plugged, and that's where Intodo comes in. So we want to be able to define what goes into a software supply chain, who the authorized people are who can perform activities in your supply chain, and ensure that nothing else happens. And this is just a quick run through of how it works. So the project owner defines a layout that contains all the operations in your supply chain, who the people are who can perform them, and what are the different artifacts that go in and out of these steps, and how they move through your supply chain. And finally, the project owner signs this, and they can choose to publish it or distribute it. Now, when each of these authorized people, they start actually performing these tasks, they generate certain signed attestations that capture what was done in the step and what the result was. And finally, all of this metadata is put out there with your package. So Intoto's verification workflow then goes in and matches all of these signed attestations of these steps with the original layout and checks if there were any deviations. We have a demo of this up on our GitHub, which walks you through a sample supply chain, what the metadata would look like in that case. And all of the tooling that I just quickly ran through in the previous few slides is available in our reference implementation that is completely written in Python. And so I'm wrapping up. Software supply chain security is, we all believe, very important, because if you're writing software that happens to be used by a significant number of people, you become a means for attackers to target all of these people. They're not just attacking you. And there have been cases of nation-state actors attempting supply chain attacks to get to end users. And we're working actively with the Debian communities, the Arch Linux communities, the reproducible builds community, and Datadog is in fact using Intoto metadata in production to have paper trails that they can verify for all the integrations that go into their agents. And that's it. Thank you.
Do you have time for questions? I don't know. Does he have time for a question? That's not really a lightning talk thing, but I'm for it if he has time. Max? 30 seconds. Let's make this interesting.
If I hacked into the build server and changed something, very quickly during the build process, it gets hashed by this thing, and then the next step checks it and it's valid. Is that prevented by this?
I'm not sure I got your question entirely. Could you repeat that?
Answer yes or no.
I didn't get the question.
Yeah, you don't get a choice.
I can talk
yes
to you
or no. All right. The answer is fall asleep and dream a dream, whatever that answer gives you. All right, let's give it up for that speaker. And next we have up Paul here. Paul, test your failures with Xfail. And while he's getting set up, here comes another little bit of trivia with you. How do turtles like to read? That's not the right answer, but fantastic. Anyway, I was going to just say hardback, but boom! That's right. If you groan, I shine. All right. Who said with tortoiseshell glasses? Well, you're way far back there. Nah, no. You got to be like in the first half of the room for me to give you a book. No, I will get you a book come up in the after the talk. All right, everybody, give it up for Paul.
Hi, everyone. I am Paul Gansel, and today I'm going to talk to you about what to do with tests that you expect to fail. Okay, so here is some function that I wrote, and it is called isPerfectSquare, and as you can imagine, it checks to see if an integer that you pass it is a perfect square. So I write this function, and I go, I'm going to write some tests for it, and I go, all right, here's a list of like a bunch of things that are perfect squares, and I assert that it's always true. And then I have another one that says, here are the things that are not perfect squares, and I assert that those are all false, and I have 15 tests, and they all pass. And it's like, great, this test is perfect. It's Friday afternoon, ship it to production. And then, like, I don't know, next Monday, right before stand-up, I'm like, oh, wait a second, I didn't check if any negative numbers, like what happens if you pass that? Oh, it's a huge error. But luckily, we don't try and check anything with negative numbers. So it actually doesn't matter. So I have this test, and I'm like, I don't have time to fix this. I have like a whole bunch of other things, and this isn't like a real issue, so I'm going to put it as like a low priority bug and just put it in the issue tracker. But like, what do I do with this test? Because I already wrote a test, and this test should go in the test suite because this is a test that should actually be passing. It's just not passing because I don't have time to fix the bug. Luckily, there's a decorator for that in PyTest. So you can do pytest.mark.xfail, and you decorate it, and you say, yeah, I know that this is failing. It should pass, but I wrote my code wrong. And so that's what this means. And what will happen is it'll run the tests, and it'll run this, and it'll give me a little X that says, this one failed, but you told me it was going to fail. OK, so then the next Wednesday, I'm like, oh, this is obvious. The domain of the function is such that, like, if you pass it a negative number, it's just always false, right? So I can just add these 2 lines, and I fixed my issue. And now, when I run my tests, you can see that the little x that used to say x fail now is a big X, and it says x passed. And that's basically the difference between the x fail decorator and the skip decorator, because the skip decorator doesn't run the test at all. The x fail decorator runs the test, reports the result, but then doesn't fail the test suite if the thing fails. But maybe I actually want it to fail. I want to treat failing to fail as a failure. So take 1 second for that. But actually, this is fairly useful, right? Because I'm saying, I expect this to fail. And if my expectation is not valid, I would like to be loudly notified about this. And that's where strict comes in. So you can say strict, and that says, all right, run this test. And if it passes, that's a failure. And then stop everything so that you can actually remove this and say, hey, regression test. So here's my example. It's failing. And in fact, I find this so useful that instead of having to decorate these things one at a time and say all of them are strict, I just put in my setup.cfg under the PyTest tool section, xfail strict equals true. And that makes that the default. So by default, every one of the xfails that I put in any of my code bases are all strict. So why should I care about this? For one thing, this documents your acceptance criteria. So I have some bug that I've filed, and I said, like, you should be able to fix this bug. And I actually have a failing example. I have a test that should be passing, and I have a test that should be passing. And actually, the speaker who was supposed to have this slot is texting me right now. So I have a test that should be passing, and when it is passing, you can close the bug. So if I just check that in with xfail, once you remove that decorator, you can actually close the bug, and it's great. This also tests your tests, right? Because especially if you're using strict xfail, what happens is you can't even check it in unless the test was failing before, and you can't fix the bug until the test starts passing. So you know that your test actually tests the thing that you care about. It also imposes regression tests early. So you may have like 500 bugs or something, and then any random change you make to the repo might accidentally fix one of these things as a side effect. And you don't want to have to double check that all of your bugs may or may not be good regression tests for something. And so what you do is you put in the strict xfail, and then you get a failing test suite the second you fix the bug. So you get regression tests the second you fix the bug. All right, that's my talk.
Thank you, Paul. You were getting me a little bit testy there. All right. Guys, gals, let's take it one deep breath at a time if we need to make it to get through these puns. They are fantastic, by the way. All right. Says one clap. I appreciate that, yeah. All right. So a couple announcements while he's getting set up. We have a social event after this event. It takes a very long time to get there. You walk through those doors. That's all you have to do. You'll get your exercise going through the 10 feet of hallway, and in will be food, trivia, books for the trivia, fantastic company. Make sure to join us there. If you need to RSVP, I don't think that actually matters anymore, right, John? All right, great. Hands up. I would say go ahead and do a little bit of RSVP just in case the statistics help us. And then the other thing I want to make a note of, if you purchased a t-shirt, make sure to pick up that t-shirt before lunch tomorrow. Otherwise, they go back on the market, okay? Somebody else can buy up your shirt. How you doing, Andrew? You ready to go? I can hear you, but I don't think they can just
Can
yet.
anyone else hear me?
There we go. Fantastic. All right, give it up for
Thomas?
Thomas. Thank you.
All right, so I'm Thomas. I'm a core dev for scikit-learn, and I want to talk about experimental features for scikit-learn. So how many of you have used scikit-learn? How many of you are familiar with the deprecations we have? We don't really, yeah, so we go through deprecations a bunch of the time, and it's not pleasant, but we do it because we think that the previous API is just bad, and we want to make it better. So we don't like it. But we still want to add new models and new estimators and all the other stuff. So we have designed something called experimental, right? So in the past, how do we say something experimental? Well, it's in our docs. Because everyone reads this and see clearly that says experimental, right? And you know that the column transformer is experimental. How many of you have used column transformer? Okay, so column transform, for those who don't know, it allows you to specify columns in a pandas data frame and do transformations on them. So you don't have to do a transformer on all the data. You could do it on parts of your data, which is what you do when you have a pandas data frame. So use it. It's cool because in 0.21, it's not experimental. You see? All right? That's how you know. This red box is not on the site. I just put that there. So there must be a better way, right? This is crazy. So now we have, in 0.21, released something called the histogram gradient boosting classifier, which is our version of LightGBM, and uses the exact LightGBM algorithm, and it's very nice. It's experimental because it's very explicit. You have to import something that tells you to enable histogram gradient boosting, and then you can import the other thing. So if you don't write the first line, it'll just crap. It'll give an import error, all right? So let's say you upgrade to 0.22. If it's still experimental, you still do this. If it's promoted, they both work. So the first line would be a no-op, and then now you could just import histogram gradient boosting classifier, right? It's great. So, I mean, so this import statement must be crazy, right? Like this must be import hacks or something crazy, right? Like if you think about how to implement this feature. So let's talk about it. Well, we have the definition of the class in a file somewhere. And the implementation of that file, the enable histogram gradient boosting file, is just this. This 10 lines of code is what we do to enable this experimental thing. So this is a very explicit contract. When you have a user import and enable histogram gradient boosting, we're telling the user that it's going to change. It may change. We're still fixing up this estimators, and they may be breaking changes. So it's a contract that we like to have with our users. And we have two experimental modules in 0.21. One's the histogram gradient boosting, and one's the iterative imputer. It's nice to bring these out so that users could use them and help us see if there's any bugs and whatnot. And that's my talk. Use them. It's great.
Thank you, Thomas. Fantastic. All right, well, Kat is getting set up. Where do you find a turtle with no legs? Right where you left him. All right, so we can mark off slightly darker humor from what's acceptable for this particular audience. Let's turn up the joy maybe here a little bit. What if you take Kool and the Gang and you put them into turtle costumes? What do you get? A celebration, my friend. Oh, yeah. I like causing pain. Let's see. What do we got here for maybe a little bit more of your... Oh, here's a fun one that's maybe not as painful as a pun. What are the Ninja Turtle weapons? Can anybody name those for me? And you get a book. There's books on the line here. Oh!
Bow staff, katana sword, nunchucks,
Dang. Yeah. And I think everybody here is very happy they didn't have to go through another one of my puns during that moment. So that clap was a little bit for you. Do you want that one or do you want the other book? Okay. Swap it out if you want the other one. Great. Let's see what else we got here. Oh, and no more answers from you because you seem like you're going to be a Ninja Turtle expert here. You've already won a book. So ending it there for you. What's that?
Here on the half shell.
Here on the half shell? Are you a Ninja Turtle celebrity? Yeah. Oh, I'm ending my social life right now with all these jokes. Yeah. Oh, are you ready, Kat? Great. Thanks. Yeah. Give it up for Kat. Thanks, everybody.
Okay, cool. Turn the mic on. Can everyone hear me? Okay, cool. I'm here today to talk to you about why your tech company should recruit from philosophy departments. I myself was a philosophy major. My name's Kat Hartling. I was a former philosophy professor at various colleges in New York City, and I left academia, and now I code. I went to a boot camp in San Francisco called Hackbright. So, since leaving academia, I became the dev intern for a startup called Jackpocket. You can buy lotto tickets and check out lotto results through our app, and we are currently hiring. So if you're interested, come talk to me afterwards. But back to my original point, have you heard philosophy majors make great software engineers? And one of my favorite programmers / software engineers, Neo, I'm sure we're all familiar with him. So we already know logic. This is a truth table. All philosophy majors have to take logic in college. That means we know Booleans, and here we have negations and conjunctions and conditionals and disjunctions. We also already understand classes thanks to Plato. Thanks for laughing at my slide. So classes are like Plato's theory of forms. Here we have the form of cat, kind of like me, and then every cat partakes in the form of cat. And Plato thought that there was an ultimate form of reality, which was the world of the forms, and everything in our world participates in that. So forms are kind of like classes in that there's instances and they inherit from the form or from the class. And also, being a philosophy major, it's pretty hard to get a job. There's kind of only one job we can have, actually two. You can be a barista, or you can be a philosophy professor. So hiring philosophy majors solves our paradox. So you should definitely hire more of us. And actually, it's funny because quite a few people from my grad department defected from philosophy and are now doing software engineering. And also, if you hire us, we'll make your lunches more interesting. We like to think about the deeper meaning of things, so, that makes for better conversations during lunchtime. And here is one of my favorite memes, the Velociraptor. So here's something, this is an example of a conversation we might have with you at lunch. If dogs like sticking their head out the car window, why don't they like it when you blow in their face? Okay. Not all philosophy majors. So don't hire all of us, but definitely some of us are good at logic. And some of us might be good at comedy too. So if you want to keep in touch, my Twitter is A Cat Once Said. And I just want to take this opportunity to thank my friend Marielle, who has supported me through my coding journey, and my mentor who helped put on Pi Gotham, Dan. So thank you guys for supporting me.
Thank you, Kat. And we've got Julian. He's going to take a little bit more time to get set up there. Can you start setting him up? Awesome. All right. So want to start off with, just in case the turtle with no legs joke offended anybody, I really didn't mean to offend anybody there. And I want to say sorry for that. So who is the fifth Ninja Turtle? Venus. Venus de Milo. Absolutely right. Fantastic. Do you want a book or a book? You'll take a book. Fantastic. Do you want Code the Game or classic computer science problems? Yeah, that's right. Yeah. Fantastic. There we go. Let's see what else we got here. Oh, and Julian, are you ready to go? Not at all. Okay. So we're going to do a few more here. What are 4 types of genetic mutations? And this is not a pun. This is just, let's see who really studied in biology class.
Frameshift mutations, loss of a stop codon where it doesn't belong. I mean, there's two.
Okay. I will give you one half of a book. So, but then that's fantastic. Great. Insert.
Single nucleotide polymorphism.
And recursion? I really appreciate that. Let's add any word to shun, and let's see if that works. Deletion, recursion, and greed. You did fantastic. You did fantastic. What's that? Missense? All right, yeah, I'll keep on going here. Let's give it up for Julian and these 2-1 books.
Thank you. Hi, everybody. It's 6 o'clock, and we're going to talk about math, hopefully, for 5 minutes. So I like coffee. I bought a coffee grinder. It cost $212.07. I paid, not in cash, but for expository purposes, let's say we did, with $200 bills and two $10 bills, meaning I gave $220, and I was given back $7.93 in change. The algorithm that everyone can do, despite not knowing it, to give out change is quite simple. People basically go, well, $7.93, the biggest bill that fits inside $7.93 is a $5 bill. And then you can't fit any more $5 bills, so we can give a bunch of $1 bills and then a bunch of coins, but I couldn't find transparent images of them very quickly. That algorithm is what we call a greedy algorithm. It's a multi-step problem. We take a bunch of choices at each step. We have some sort of metric or cost that we use to decide how to value each of the steps, and then we pick the best one at any given point. Another example, I'm from Brooklyn, although I don't live there anymore, but if I need to go back again, in theory you could drive from here to Brooklyn, and you've got two choices. You could either make your way to the West Side Highway, which from here probably takes about 10 minutes in a car, especially during rush hour, or you could choose to drive down Broadway, which is relatively close and probably takes about 3 minutes. The issue is if you pick the first one, you're probably getting back really quickly because the West Side Highway, even during traffic, is pretty reasonable, whereas you're going to stop at every light if you choose Broadway. And so the greedy algorithm doesn't work very well here because even if you pick the one that's 3 minutes, you're going to spend a lot more later. So when does greedy algorithms work? How can we define which cases a greedy algorithm works and which cases they don't? So let's add a word here, and the word that we were missing was independent choices. So greedy algorithms work when you are able to make independent choices at each of the steps in your problem. And because I promised math, we have a nice word for that. It's called a matroid. It's a fun little algebraic structure. So what's a matroid? It's a set of elements, so it's some stuff. And then this notion of independent subsets of those stuff. So what does that mean? So we say that you have a collection of independent sets if, first of all, the empty subset, meaning if you take no things, is an independent set. Then if you have an independent set and you take something out of it, that thing also has to be independent. And then if you have two independent sets and one's bigger than the other one, then there should be one of the elements in the bigger independent set that you can take out and add to your smaller independent set and still have an independent set afterwards. So there's these three properties that define essentially this algebraic structure called a matroid. And the nice, fun math theorem basically tells us that matroids are both necessary and sufficient for greedy algorithms to work. So if you have some problem that you can express as a matroid, it turns out a greedy algorithm will work. And if you have a problem that a greedy algorithm works on, then there is some way of actually phrasing your problem in terms of independent sets. Monads get all the publicity, but matroids are pretty cool. Thanks.
Thank you, Julian. All right, next up on deck, we have Timothy. And while Timothy is getting set up, what do you call a turtle running on a 9-volt rechargeable battery? Shell shock, pretty darn good. You get at least a few pages from a book. Anybody want to take another shot? A Durashell. Boom! Fantastic. Oh, did you just like Google different tortoise jokes? Oh, there we go. Oh, that was you? That's it? Yeah. Fantastic. You get a book. I'm marking these off in my head. Okay, in the movie Teenage Mutant Ninja Turtles 2, Secret of the Ooze, just to be clear here, what rapper, gosh damn it. Yeah. Oh no, I did not say that. I said, gosh dang it. This is not a good afternoon for Paul Logson. All right. Say what? Speaker's ready. Thank you. Please give it up for Timothy.
Hey everyone, I'm Tim. I write code for the Wharton School of various open source projects, and most importantly, for myself. I help organize DjangoCon US and the Philly Python users group. I started writing code when I was age 6 and absolutely love it. My godfather was actually the guy who wrote the assembly code for that memory game Simon and sold it to Mattel for a one-time fee instead of a percentage of sales, which, yeah, kind of sucks. But I consider myself very lucky to get paid what I'd love to do with colleagues and friends that are close enough to be considered kind of a second non-DNA family. So this is what my GitHub contribution chart looked like in 2014. Did that look like the chart of somebody who absolutely loves to write code? The truth is, in 2014, I wasn't doing what I had loved. I had been slipping further and further away from doing what I really loved for a long, long time. And while I still worked hard and had a lovely home, squaring who I thought I should be with how I acted was getting harder every day. And looking at the guy in the mirror every night was getting harder and harder. So this is 2015. It was because of this that I had to change just one thing. So what happened right here? For many, many years, I had been trying to change just one thing on my own and failing. Finally, in April, I asked for help with my alcohol addiction problem. In May, I got out of rehab, and I've been clean and sober ever since, one day at a time. And you can see, as soon as getting out of rehab, it's a pretty good visual indicator of what can happen when you change just one thing. So what happened here in July and August? I made a really, really tragic mistake and reopened my World of Warcraft account. So 2016 seems to have been a lighter year, but I was working in some private repositories in our local Bitbucket installation on premises, and also working on a little event called DjangoCon US 2016, which we held in Philadelphia. No way I could have done that if I wasn't sober, and really one of the highlights of my life. And then by 2017 is where I really hit my stride. I'd gotten involved in more open source projects. I had found a new purpose in life. And we started to open source some of our own packages we were building at the Wharton School on GitHub and PyPI. And as you can see now, I'm pretty active in doing what I love, writing code with a community of friends, old and new. So I want to ask everybody here, if you could change just one thing about yourself, what would it be? If you need help to make that change, I want to encourage everyone here, don't be afraid to ask for help, especially in this community. No one is perfect, and we all need a helping hand sometimes. And to your left, to your right, you've got people willing to help you. The Python and Django communities, I got involved in Python and Django right around the same time I got sober. And I think it has been a major influence in helping keep me sober by giving me a purpose and something to do instead of drinking and drugging 6 hours a day on average. By reaching out and meeting people who didn't just look at me as some kind of addict, but as a person who needed help, who has a disease, who can do better moving forward. And I found that support in this community just as much as I did in recovery groups. And it's been incredibly important to me. So I want everyone here to know, if you think you have a problem, you probably have many friends in this room that you don't even know you have who would be willing to help you out. Maybe who've already been through the same thing you're going through right now, that makes it hard for you to look in the mirror right now. And that you can change that one thing. And as Gandhi said, we must be the change we want to see. in the world. So if you need help, ask for it. If you have a problem, whether it's addiction or anything else, sometimes changing one thing can change everything. Thank you very much.
Thank you, Timothy. Thank you. Okay, we have Anuj. There we go, great. All right, so, give a little bit more time. And make sure that if you've answered a question correctly, or at least half correctly, you come up and get those books. Hey, that was bravo, just as is. Don't turn your eyes down for that one. So, we as human beings are born with a certain amount of genetic mutations. That just out of the gate, we are born with a certain number of them. What is, and you can't answer this because I already see the smile of joy coming over your face, like, here I go. I'm getting another book, and everything just got a little bit more intimate. What's going on here? Getting a little bit freaked out. Is this part of your talk? Oh, this is definitely part of your talk. Okay, I'm going to let things ride how they are here. Anybody want to give a guess at how many mutations we are born with on average? 200. Interesting number. I heard 1,000 up here. Does anybody want to take 20 million, says the person who has a giant brain. One. Interesting. And now we're back in light. I was kind of looking forward to that dark lightning talk, actually seeing lightning in the room. I'm going to leave this one up. Think about it. Don't Google it. No, you're going to Google it. Give me one more shot. 100,000. 100,000? 23. 23 and me. Nope. But very close. I'm going to give it to this. I'm sorry, was it you? Yeah, I'm going to give this to this gentleman. 60 on average. 60, only 60. The rest we get through a lifetime of sunbathing. All right, so let's give it up for Anuj.
Hi everyone. My name is Anuj. I did not really prepare a presentation for the lightning talk because I never thought they'll actually accept my form. So this is an old presentation. Sorry for that. A quick show of hands. Any GRE, GMAT test takers here? Any fans of Big Bang Theory? Okay, so when I was actually giving my GRE, I had to learn loads of new words which I never came across in English. So I made myself a very small tool called, I simply used Python to, Big Bang Theory, Sheldon uses a lot of words which I never knew. So I just put them together. I wrote there was this library which helped me just, the input to the library was a video and it truncates or it identifies clips where a specific word was used and just puts them all together. And I used it to learn words because that actually gave me a lot of context. I didn't have to actually memorize new words. I could just this is what Sheldon used it for. That is how I actually tried to remember it. I'll just show a very quick demo because that is all I have. Hold on. Just a second, sorry about this. I think so. Yeah. With audio? Yes. Is that possible?
You gotta talk about that beforehand.
Oh, sorry.
This is where I make my money, y'all. And actually, they turned down the volume on my microphone, so I'm gonna be a little bit louder here.
Okay, we'll just play it like this, I guess. So this is this is the result for the word love from one of the episodes of Big Bang Theory.
You know, I fell in love with Leonard because he wasn't anything. Can we talk?
I would love that.
You know, I fell in love with Leonard because he wasn't anything.
Probably why it took her so many years to tell me she loved me.
Maybe you should.
You'd think I'd be used to women withholding their love. I mean, my mother, I've loved you since the moment we met, and I will keep loving you. Beautiful, and your beauty fills my heart with love and song.
So that is the output of the code. It was a very simple Python library, so I just wanted to take a moment to, you can use different libraries out there just to make your life a little bit easier, and that's what I did. Thank you.
Thank you. Woo. No, you're good. All right, so we are in our home stretch of lightning talks. We have 2 more. All right, we have Jonathan here, and then we have Mohammed. Just a friendly reminder, please do join us for the social event just right through those hallways, or through that hallway. And then the next question on our list, oh, this is a fun one. Why do Ninja Turtles make terrible office mates? Seems like you know the answer, sir. They only order pizza? Frankly, that seems like a pretty great office mate. They spread salmonella. They eat all the pizza. That's great. They're in-shell-verted. That's also great. These are all really good. They're always destroying the shredder. That was the one I had down. Yeah, absolutely. Yeah, all right. Yeah, that was about appropriate amount of clap for that one. You all set, Jonathan? You good to go? Fantastic. Everybody give it up for Jonathan.
Hello, hello. All right, you can all hear me now. Thank you guys for hosting this. This has been phenomenal. And for all the talks, it's been really great. So getting started, I'm going to talk to you all briefly about structured logging in Python. What it is, how you can implement it in your organization, and well, mostly that. About myself, my name is obviously Jonathan Meyer. I work as a software engineer at a company called OpenSlate. And when I'm not doing those things, I enjoy reading, writing, running, and rowing. I can't say it too fast. It's a lot of R's. All right. So what are structured logs? Well, the basic idea behind structured logging is that we write our logs in a consistent and machine-readable format across as much of our application architecture as possible. This allows us to easily run kind of higher-level analytics queries against our logs to understand what our application is doing. So an example question that we might want to answer and be able to answer through our structured logging is like, what query parameters are associated with my longest running HTTP calls? So this is, at OpenSlate, we've just kind of been moving towards this model around our logging. And this is an example of one of the structured log message shapes that we kind of chose. I'll just focus on the top 3 keys here. But this is a log message that we emit whenever one of our internal services calls another internal service. So we emit the elapsed time for the HTTP call, the URL that we hit, as well as a key with the query parameters that we used for the call. So if we imagine that this is some search service that we're hitting, we can really easily write a little script that will analyze our logs and give us a list of the 10 slowest running queries. And as a result, we can see the query parameters associated with those. So structured logging, this is great. How can I bring this to my organization? Well, I'll tell you how we rolled it out, and it's going to be different for every org, especially if you're big. We're relatively small. So this is what we did. First, we set up like a generic logging utility package that we could share across all of our projects that gave sensible logging defaults. Second, we sat down and hammered out the keys that we wanted in our structured logging documents. This is by far probably going to be the most painful part of this process, especially if you're in a large organization with a lot of people who have strong opinions. But I don't know, it worked for us, and I hope it can work for you too. And then finally, what we did is we just slipped a JSON formatter as the default in our in our logging utils module. And so as soon as each project updated the logging utils package, they got this JSON logging for free. And shout out to Hynek, who maintains the struct log package, which is what we used for this. So it was, yeah, really, really cool and great experience. Then I guess as a bonus, you can send your logs to an aggregator like Logstash and dump it into Elasticsearch. And you can configure Elasticsearch to index the fields of the JSON documents that you're writing into it, so that suddenly you get all of the power of like Lucene queries on all of these fields. So that's pretty cool too. But even if you're not running a log aggregator, having things in a standardized format can really help. So yeah, that's about it. That's my whole talk. If you have any questions or whatever, you can hit my email at jonathanwmeyer@gmail.com, and Twitter is it's the same. So thanks so much, and yeah.
Thanks, Jonathan. All right, so while we are getting Mohammed set up, what is the difference between a tortoise and a turtle? Yes. There you go. Absolutely. Yeah, tortoises like to hang out on the land, turtles in the sea. Do you hang out with a whole lot of turtle-tortoise pairs? Do you study? Really? You lived with, let's break this down. You lived with a tortoise in the backyard. Was this a stray tortoise or was this your own tortoise? It was the owner of the house. I think we need to cancel whatever is going on right there. We need to have you go up there and explain whatever happened that time. But we are already set up for restructuring data.
I'm not shelf-centered here, right? If you want to, I don't want to be shellfish with all this time that I have.
Oh, man.
5 minutes.
Listen, I don't want to put this person any more on the spot. He's already done fantastic. So let's give it up for Mohammed, everybody.
All right. Thank you. Okay. So yeah, today I'm going to be talking to you guys about restructuring data in Python. It's a pretty good dovetail with that last talk. You're going to have a lot of structured data with all those logs. So let's start with a quote. Who's heard this one? Flat is better than nested. I hear some fans of this statement. You know who said it? Tim Peters and PEP20, it's a rather famous thing. Import this, the Zen of Python. But then there's this other quote, right? It says, namespaces are one honking great idea. Let's do more of those, right? Now, these two statements, there's also Tim Peters, also PEP20, right? So it's like, okay, so which is it, Tim? Do we want it flat or do we want namespaces? And so really this is what makes it a Zen. You got these nice tensions going on. But the fact is that in the modern age, a lot of data is extremely nested, right? And so it doesn't matter what Tim said, they went ahead and nested it. And in fact, just looking at this data here, when you nest things, it sort of impacts like discoverability. I found APIs that just repeat whole data structures, just the same thing twice. Sometimes they don't even agree exactly. So, nested data is a bit of a bear. And to resolve this, I bring a library, right? It's called GLOM. It's Python's nested data operator. So you can check it out right now. It's on GitHub. This link will be up later, but I'll continue to talk over this as cell phone cameras respond. There we go. OK. So what does GLOM do? So GLOM is a simple function, right? You take some nested data. In this case, I've got a little model of the, space. And basically, you can just say galaxy.system.planet, and it does a deep get on this dictionary. And so the output here is going to be Jupiter, because that's the galaxy key, the system key, the planet key. You got it. All right? This is the simplest form of using GLOM. And what happens if you don't use GLOM and you do something like this? You basically get, attribute error, target type has no attribute A, key error B, none type has no attribute get item. These are all sorts of different errors that you can get from this one line, and not all of them make this line very debuggable. So unless you have a stack trace and maybe a crystal ball, you might be out of luck. The good thing with GLOM is that it'll tell you it could not access C index 2 in path A, B, C. So you get a really sort of coherent, like debuggable error message from any sort of like path access error, which is what we call that deep get failure. So the thing is, we took it to the next level. This is Python after all. It's one of the most expressive languages out there. We can do a lot more with this. And so when you have whole data structures that you actually need to template, right, you can just sort of nest these GLOM specs and evaluate it all at once and restructure the data. So this is what GLOM's like sort of raison d'être is, right? You just are able to template data and transform it. One time I worked at a place and we had a, what do you call it, a Django template called, let's say result.json. And it was just using Django templates to create that JSON file, as opposed to dumping it into a dictionary and then using JSON dumps to output the dictionary. So GLOM is sort of the solution to hacks like that. Other features, so you get that path-based access and assignment. So you can do deep assignment into mutable data structures. You get declarative data transformation, readable, meaningful error messages, and it even has, though I don't have time to demonstrate it here, a built-in debugger for debugging your GLOM specs, because any good programming language has to have one of those. And it also comes with a command line tool. This is basically like JQ, if you've heard of that, but it's written in Python, and anything that you use there can just be immediately pulled into a Python program, unlike having to interact with JQ through the command line, through a shell, through a sub-process. So that's GLOM in a nutshell. Definitely check it out. We're working on some really cool stuff around streaming and pattern matching. So yeah, check it out. Pip install it and see the docs. Thank you.
Awesome. Thank you, Mohammed. All right, so we have one surprise last speaker. A little out of order, but give it, well, actually, Dustin's going to get ready for a second. So, what ingredient is not welcome on a Ninja Turtles pizza? No comment. Anchovies. Fantastic. And you seem like you might know. Why is that? Because they don't like the taste of it. Hey, that works, right? I still have a question about that. As I watched as a child, I still never understood why. Why hate the anchovies? Okay. We have done a fantastic job of moving these speakers through. They've been on time. I haven't had to push any one of them off. And look at that. We're running and right up ready for the next talk. Stick around for our last talk of the evening. Give a very warm welcome to Dustin.
Hey, everybody. Hey, so I'm Dustin. I do developer advocacy at Google, which means that I care about Python and Google Cloud, and mostly the intersection between those two things. And we have a lot of Python stuff, so really that intersection looks like this, but occasionally we do have a product that doesn't actually have a Python runtime or client library. One example is Cloud Run. I'm super excited about this product, and I want to tell you about something I did with it. Cloud Run is stateless HTTP containers. Basically, you can think of it as Docker images as a service. So all you have to do is create a container that does these things, listens on a port at a certain address, and starts the HTTP server in 4 minutes. And then you can just deploy it to do whatever you want. So for example, you could write a Flask app that looks like that, define your dependencies, write a Docker file that inherits from Python 3.7 and installs requirements and things, and then you can deploy that to Cloud Run. The cool thing about this is that it uses the Python-based image, which means that you can use any version of Python that you want. And actually, if you read the container contract, it says this: your container image can run code written in the programming language of your choice using any base image. So this is a nice feature, but I saw this for the first time, and I thought, I think this is a challenge. What can I possibly deploy to Cloud Run if I can use any programming language of my choice and any base image? Can I use a super old version of Python? Could I deploy like the earliest possible version of Python that ever existed to Cloud Run? Let's see. So what I did is I went to python.org and I clicked on downloads. And then I scrolled down because I was looking for a specific release. I scrolled down to this page, but they only had Python 3.2 and 3.8. So I clicked on view older releases and I got to this page. I clicked on older source releases and then I got on this page, which is that legacy.python.org, so you know it's good. And then I scrolled down to the bottom of this page, and I ended up with this file, Python 1.0.1, which was put on the server in 2002, but it's actually from much longer before that. And then with a very small patch, I only had to change the name of one function. I was actually able to get Python 1.0.1 to compile on the latest version of Ubuntu, which is awesome. So I had to do a couple things, install some dependencies, but from Ubuntu, install my patch, and then I get an actual Python interpreter with 1.0.1. So I do that, install the source, and run make lib install, and then I get Python. And so then I can run that Docker container and get a REPL. I get root too, so I'm hacked. And I can run Python. But the thing is, I can't run Python /version because that doesn't exist yet. Invalid option. What version is this? But I can start Python. I can see it says Python 1.0.1 at the beginning. So that's nice. And also copyright from somewhere in Amsterdam, which probably makes sense. But the problem with this is in Python 1.0.1, we didn't have an HTTP server yet because it was that far in advance. And I didn't want to have to backport this to 1.0.1. It says no module-based HTTP server. So I went back to this page. I picked Python 1.3, which is the first version we had an HTTP server in, which for some reason, if you notice, was uploaded 2001 to this page, even though it was before Python 1.0. I don't know. Again, had to write a small patch, again, wrote a small Docker file, again, got root hacked, and then still no version, but I could run Python, and I could get from base HTTP server import HTTP server. So we're cooking. Internet. So then you can write something like this, which if you squint at it looks like a Flask app from before, but in fact, this is the HTTP server in Python and standard library. So I can do a do get. This returns hello from Python plus the system version. And then you just run it forever. Cool. So I created Docker-based images that had this version of Python installed on it, that I could write a Docker file that inherits from this. So I created them for you, for all of you, from 1.0.1 to 1.3. Go ahead and use it. And then so you can write a Docker file that looks like this. Inherit from vintage Python 1.3, copy your directory in, start on the port, and run python app.py. And those are all those things. And then all with those two files, Docker file, app.py, you can run gcloud build submit. And it runs a really long script, and it says success, but like, really, is it success? And then you can run gcloud beta, run deploy, and you get a nice little URL. And if you click that URL, it says hello from Python 1.3. Hooray. We did it. We saved Python 1.3. All right. If this is interesting, you can check out Cloud Run. You can also check out my vintage Python. Remember, don't try this at home. Try it at work instead. Thank you.
That was fantastic to end with, Dustin. My only question is, will it run on my Windows machine? All right, we'll talk afterwards. Thanks, everybody. Thanks for a fantastic first day. Definitely shake some hands, and we'll see you later.